Okay, HoiTing, you were specifically asking me about the shading in your exercise 10. I couldn't really understand your screenshots, and so I just decided to look at the model and move from here. Okay, so first of all, I can't really run any simulations because I'm not gonna have the same templates as you do. So if I run them, they'll be different. Uh, but just looking at things, if we go from old school to energy code to high performance, we're getting the effect that we're expecting, right? So it seems like that at least most of the settings are accurate. Um, and we could, come in and look at why that's true. But the the thing that you're asking about is because for shading, you were supposed to come back to the energy code settings and experiment with some shading. So let's look at that. So here we are in the energy code, energy flows chart, and we're looking at windows. Um, we see that, and so what's the effect of the windows right now? Well, we don't have that many losses in the winter, so we could improve this by changing the U value of the windows probably, but it's not really a huge concern, and that's not what shading will do. Um, we don't have a lot of gains in the winter, and we might like more actually. So we're concerned about shading that at all anyway, anything that's happening in the winter, if we're trying to get solar gains. And then, okay, so we do have some gains in the summer that we could try to attenuate, but we don't want to, while we're shading these, also shade these. So the idea is that the winter orange above the black line is what is good. The summer orange above the black line is bad, and that's because the winter is going to be the bigger the more gains we have in the winter in the windows, the less of a heating load we'll have, so it'll cut into this. Um, and in the summer, it's the opposite, right? Okay, so then you added 5 foot shades all around the building, and the first thing you said is it didn't change, and it did change, right? So we're it just doesn't seem like very much. So we changed our site EUI is down 1 kilobtu per square foot. Um, that okay, that's not something that was probably we would do a lot of. We'd be excited about in terms of any kind of design change we'd made, but it is showing that something's happening, and let's look at it to see if it makes sense. We have between uh, the unshaded and the shaded, we're going to drop the uh, um, the gains in the summer a little bit, which is something we would want. At the same time, though, we're dropping the gains in the winter too, and we're actually getting some losses because um, when we are shading the windows when it's cold outside, we're getting fewer gains, and we're also getting more losses because there's going to be more times when it's colder outside than it is inside, and that the cold's going to or the heat's going to move through the windows out. Um, so what's happening here then is that we're balancing out the advantage of shading in the winter, I mean in the summer, over the disadvantage of shading the windows in the winter. Um, Another thing to point out is if you go to IP from IP to SI, SI is just well, it's bigger numbers, so we're going to see more gradation as things change. So if we go from it's just a little, we can see that numerically, this is just a little. This is just numbers that since it's larger, it's going to be the same percentage is going to be a larger number. The change. But I'm just saying that that's maybe something you want to do if you're wondering if it's actually anything happening. Um, then when we add the 10 foot, um, we actually get a drop. So from the 5 foot to the 10 foot, we get an increase in our um, EUI. So let me see what we had. We started with 264. The addition of the 5 foot gave us enough shading in the summer, even though we cut into our heating from the windows in the winter. We got a little bit of a bump in our energy efficiency. But when we go to the 10 foot, we actually um, are, you can see if you go back and forth, we're losing um, quite a bit here in the winter and not that much in the summer at this point. So we're going backwards, and we actually are having a higher EUI with more shading. That actually, and what I'm saying is that that's working. There's no reason to question that. And so, why is this happening? What are we learning from this? First of all, you're in the energy code, or you should be, based on the instructions. The energy code iteration, and here you have a U value of 0.45 in your glass. That's an R value of 2 in IP units. That's really pretty bad. So we're going to get a lot of heat loss and gain. I'm sorry. Yeah, a lot of heat loss in the winter and gain in the summer that's not related directly to the sun. It's just going to be the temperature outside. And then we have a pretty low solar heat gain coefficient here, 0.33. So our goal in shading is to block more sun, but we're already blocking a lot of sun with the glass. So if you wanted to see a larger effect from shading, if you went back to this setting for glass, you'll see something larger. But there's another thing that's going on here, and that's I have a different model open here. I don't know if I showed you this model in class or not, but so this is these two buildings have the same window to wall ratio. So I think let's just do it. If I go and select this surface, its area is 960, and this surface is this wall is its area is 2000. This wall, this window is 96, and the surface area of the wall itself is 200. So 96 to 200, 960 to 2000, it's the same ratio. So the window to wall ratio is the same for these two. And if you and then all the other settings were the same for these two simulations. If I run it for the small building, I get a site EUI of 234 kilowatt hours per meter squared. And if I do it for the large building, I get 122. So almost half. So this is a much more energy efficient building just by being larger. And so one thing that we changed this week then is we went to a much larger building, right? This is a 125 foot by 40 foot building. It's got 3 floors, so you're getting a lot of square footage here, 45,000 square feet. And with limited, so that limits the effect of your envelope. We also, and I think that's why I was showing you this, we have a lot of glass here. So we're going to get, well, the point being that another way of improving this, the profile of the glass is to have less of it. If we have less glass in the building, we will definitely have less overheating in the summer, and we could reduce this loss in the winter by having less glass. So that would be something to try. The summary is, I think that your model is working. I just think that as you get into the thermal analysis, it's just it's kind of nuanced and a little bit more. It takes a little bit more effort to understand what's going on. So I would say just spend some time looking at the outputs and asking me specific questions about those rather than saying it's not working. And you may find things that I don't understand, or we'll find that maybe you didn't. Like I think that, for example, like I was saying, at least I'm wondering if you changed. But by the way, so then these must be. I think when I open this I open your file in my computer, it's just going to default to some preset zones from that I've already got. Anyway, in this case, we're at 1 here, and we should be at. Well, no, you're right. For energy code, it should be 1. So maybe I'm saying that wrong. Anyway, let me think. Let me look at the. Oh, my bad. That would only be happening for in the high performance anyway. So that's the reason why um, the air infiltration is the same for these two runs. So that makes sense to me. Anyway, let me know if this did not answer your question, or don't just go, yeah, well, I tried and he didn't answer it. If you need more help on this or we need to talk about it, let's do that. We could just Zoom and meet and talk. Okay? All right. Talk to you later.